our discussion of power series. So we're going to be in section 11.9 in your book, which is about representations of functions as power series. So I'm going to take a power series that we've seen before. I think it was the very first power series we talked about, which is the power series 1 plus x squared plus x cubed, which I can write as n equals 0 to infinity, x to the n. What kind of series is this? If I take a term and divide by one before, it's a geometric series. What's my r value? X. So this is a geometric series with r equal to x. Okay. All right. We know when a geometric series converges, there's the condition on r. There's no condition on r. The absolute value of r needs to be less than or equal to 1. So this series converges if the absolute value of r, which is x, is less than 1. What's really nice about geometric series is that we also have a summation formula, right? If it converges, our sum formula is a over 1 minus r. So if the absolute value of x is less than 1, then we can find the sum of this series and it's going to be, our first term was 1 over 1 minus x. So I want us to take a minute and think about what this statement is saying. Right here. So let me scoot it up a little. On the right-hand side, I have a function. And on the left-hand side, I have a power series. So what we've done is we've represented this function on the right, 1 over 1 minus x, as a power series, but only if x is between -1 and 1. So this is what we're talking about when we're saying finding representations of functions as power series. Here's my function, and here's a power series that represents that function in some interval. So our question for pretty much the rest of the week that we're going to be talking about is the following question. So for a function f of x, how do we find a representation of the function f of x as a power series? So given any kind of function, we want to find a power series that represents that function. Okay. So this is the question we're going to keep in mind as we continue on and we do problems today.